So this video is integrated 3. This is the binomial theorem and Pascal's triangle worksheet number 1. The very first thing I'm going to do is I'm going to just add a page real quick. Maybe I'll do the grid. And just so I can draw out Pascal's triangle for myself. So let me just get this to be a 2-pager. Change it so that the show cover isn't there. Okay. So I am going to draw out Pascal's triangle for myself. Okay. So when I am doing this, I'm going to start with a 1. Next row is a 1 and a 1. Next row is a 1, a 2, a 1. Next one, 1, 3, 3, 1. Next one, 1, 4, 6, 4, 1. Next one, 1, 5, 10, 10, 5, 1. 1, 6, 15, 20, 15, 6, 1. 1, 7, and then I'll see I have to go beyond this. 21, 35, 35, 21, 7, and a 1. Okay. So for this one, I am going to be doing the row 1, 4, 6, 4. Okay, so let me just jot that down for myself. 1, 4, 6, 4, 1. Okay. So I'm going to have x to the 4th plus 4, x to the 3rd, y to the 1st, because remember they have to add to the exponent here of 4, plus 6, x to the 2nd, y to the 2nd, plus 4, x to the 1st, y to the 3rd, plus 1, y to the 4th. And that's your answer. If you want to clean it up, you can have it be x to the 4th plus 4x to the 3rd y. You don't really need the 1 there. 6x squared y squared plus 4. Instead of x to the 1st, you could just write x. Y to the 3rd plus y to the 4th. And that's your answer. Sometimes I like to have the 1 here, so I remember 1 plus 3, 1 plus 3. Okay, the next one is a 3. So I am going to be using this row 1, 3, 3, 1. That's what I'm going to be using. So let me jot that down here. Okay, I'm going to be using 1, 3, 3, 1. Okay, now in this case, I am going to be dealing with a 3x and I'm going to be dealing with a negative 2y. So when I am doing this, I am going to have 3x to the 3rd plus 3 times 3x to the 2nd, negative 2y to the 1st, plus 3 times 3x to the 1st, and negative 2y to the 2nd, plus negative 2y to the 3rd. Okay, so when I work this out, this is going to be a 27x to the 3rd. I am going to have 3, and 3 squared is 9 times a negative 2. Okay, and I'm just going to jot it out first so everyone understands that this is going to be a 3. This is a 9x squared and a negative 2y that I need to multiply out. Okay, I don't leave it like that. Here I have a 3 times a 3x times negative 2y to the 2nd is going to become a 4y squared. And again, I do not leave it like that. plus, and actually this is going to be a minus because it's going to be a negative 2y to the third, which is going to be a negative 8y to the third. So now when I work this out, 27x to the third, I'm going to take 3 times 9 times 9 times negative 2, which is going to be a negative 54x to the second y, plus 3 times 3 times 4, so 9 times 4, 36, 36x y to the second, minus 8y to the third, and that's your answer. On number 3, this one, we're looking for a term. We're looking for a term with b to the 5th, a to the 5th, b to the 7th, okay, and this is a 12. So that's going to be 12 choose 5 times a to the 5th, b to the, let me do it like this, a to the 5th, b to the 7th. So I'm going to put 12 choose 5 in my calculator. And when I put 12 choose 5 in my calculator, I get 792, a to the 5th, b to the 7th, and that's your answer. On number 4, we want to find the 4th term. So I'm going to go 12 minus 4 plus 1. So that's going to be 8 plus 1 or 9. So I'm going to do 12 choose 9 times a to the 9th times b to the 9 plus 3. So when I do 12 choose 9 in my calculator, I get 220, a to the 9th, b to the 3rd, and that's my term. On number 5, the probability of a weighted coin, so this is not a fair coin, a weighted coin is 0.62. If the coin is flipped 6 times, what is the probability that exactly 4 times you're going to get heads? Okay, so the probability of heads, put H here, is 0.62. So the probability of tails, which is basically not heads, is the rest of that, which is going to be 0.38. Because together they have to add to a whole. So since there were 6 tries and we want exactly 4 of them to be heads, I'm going to take 0.6 choose 4 times 0.62 to the 4th and 0.38. Since there's 4 successes, that means there are 2 failures. And I'm going to put this into my calculator. So 6 choose 4 times 0.62 to the 4th times 0.38 to the 2nd. I end up with 0.3201 if I round up. So about 32.10%, but you can leave it as the decimal. Now this is a little trickier. This one's at least 4 times. So that means 4 or 5 or 6. Now, sometimes it's easier to find what we didn't want. What we didn't want was 0, 1, 2, 3. That's more than this. So unfortunately, I'm going to have to find all of this. Okay. So I'm going to be doing 6 choose 4. And I'm going to be adding that with 6 choose 5. And I'm going to be adding that with 6 choose 6. So I'm going to have 6 choose 4 times 0.62 to the 4th and 0.38 to the 2nd, plus 0.6 choose 5 times 0.62 to the 5th, so 0.38 to the 1st, plus 6 choose 6, and I've got 0.62 to the 6, which means 0.38 to the 0. And I'm going to put this into my calculator. A couple of things just to kind of remember is the 626 is just a fancy one. This also is just a fancy one. So I don't need to put that in. You might remember that this is the same as 6 choose 1. And 6 choose 1 is a 6. But again, I can just put that into my calculator. So I'm going to put all of this into my calculator and see what I end up getting. And when I put all that in, I ended up with 0.5857. So about, I don't know what I'm drawing there, about 58.57%. So hopefully this helped you out if you were having some difficulty with these problems.